Let's now work several examples together. Solve each quadratic equation. Simplify all radicals. Example 1a, x squared equals 121. We begin by observing our quadratic equation is of the correct form. Quantity squared equals some positive value. Because it's of the correct form, we simply apply the square root property directly. Recall, the square root property says that if a quantity squared equals k, then that quantity is equal to the positive square root of k or the negative square root of k. How does that work over here? X squared equals 121. That means our value x is equal to either the positive square root of 121 or it's equal to the negative square root of 121. What's the square root of 121? That simplifies to simply 11. So that means x is 11 or x is negative 11. This creates for us the solution set of two numbers, negative 11 and 11. We should always finish our answers by checking. So let's put them back into our original equation. And we're going to check. If we put 11 in for x, that's checking to make sure that 11 squared equals 121, and sure enough, 11 squared is 121. Same thing, if we put negative 11 in and square it, that likewise gives us 121. And that tells us that these two answers are the solution to this quadratic equation. Example 1b. Solve the quadratic equation y squared equals 72. Notice that once again, our equation is written in a form that we can directly apply the square root property. That is, a variable quantity squared equal to some positive number. Recall, our square root property says that if a quantity is squared equal to k, then that quantity is either the square root of k or the negative square root of k. How does that apply here? Well, y squared equals 72 means that y is equal to the positive square root of 72 or it's equal to the negative square root of 72. All that's left for us to do is simplify this radical. Now, 72 is not a perfect square. Therefore, we have to do a little work in order to take the square root of 72. Let me do that down here. Square root of 72, well, that's equal to 36 times 2. I know that. And if we like to break it down farther, we can see that 36 is a perfect square. It's 6 times 6. Because 6 times 6 is repeated twice, or the square root of 36 is just 6, we can pull out that factor 6. And therefore, the square root of 72 is simply 6 times the square root of 2. That means that y is 6 times the square root of 2, or y is negative 6 times the square root of 2. Let me show you that notation that some books will use. They will simply use the plus or minus to make it a shorthand notation and write it as plus or minus 6 times the square root of 2. But notice this simply means the two answers, and we'll write that as our solution set. Negative 6 times the square root of 2 and positive 6 times the square root of 2. Let's box our result. I'm going to leave the check to you, but make sure that when you take these two values and put them back into your quadratic equation, they give you something true, which they will.